Write down thermodynamics. We'll start with first law of thermodynamics. And with the help of law, you will understand everything. First law. What is first law? Delta Q, delta U, delta W. Or we prefer dq, du, dw. This is first law. What is this? Let's write down first what these terms are, and then I'll explain what an easy equation this thing is. Write down what dq is. dq is heat supplied to a system. dq is heat supplied to a system. There is a cylinder covered with a piston. There are gas molecules inside. These gas molecules, this is your system. आपने इसको गर्म करने की कोशिश की. That's dq. So what is dq? Heat supplied to a system. But once I write d, I should be careful with plus and minus things, and therefore write down the next part. When heat is supplied or given to the system, when heat is supplied or given to the system, dq is positive. dq is positive. And when heat is rejected by the system, when heat is rejected by the system, heat comes out. Then dq is negative. dq is negative. Remember, it's about visualization of heat, temperature, and these things. Because of that, we are studying thermodynamics. So let me ask you this question. You have a cup of tea in a room. During winter season, you hold a cup of tea in your hand inside a room. For the air inside the room, what is dq? Positive or negative? Answer this in the comment box first. For the air inside the room, what is dq? Positive or negative? Good, almost all the answers are correct. dq will be positive. Cup of tea, it's hot. From hot cup of tea, energy is transferred into the air molecules present inside the room. That means what? System air molecules, they are receiving heat energy coming from that cup of tea. If heat is supplied to the system, dq is what? Positive. And therefore I hope you understand that for the cup of tea, dq will be what? That cup of tea is rejecting the heat. Heat is coming out, and therefore dq is what? Negative. This is the meaning of dq. In fact, you can write this example also so that any confusion whatsoever you may have, because I saw that one of you wrote negative for that. So just to avoid any confusion, write down the example also. If we have a cup of tea in a room, if we have a cup of tea inside a room, then for the air, dq will be positive. But for the cup of tea, dq will be negative. If you reject, negative. If you accept, positive. That's how we define dq. Now this U stands for internal energy. So what is du? Change in internal energy. Write down this next line as our next point. The first thing about dq, that was the first point. Now for du, write down the second point. du is change in internal energy. du is change in internal energy. A brief idea about internal energy. Internal energy means energy of these molecules. It has two things. One is kinetic energy. As they move, they possess what? Half mv square. If they rotate, they also have what? Half I omega square. We'll discuss these things, but it's very easy. All the molecules which are moving and are rotating, they will have what? Kinetic energy. Translatory and rotational, depending on their configuration. And they also have what? Potential energy. Sum of this kinetic and potential is basically what? U, internal energy. So when you say du, change in that internal energy. What is internal energy? Sum of kinetic and potential. So continue with the statement. First of all, du is what? Change in internal energy. Internal energy is due to kinetic and potential energy. Internal energy is due to kinetic and potential energy of the molecules inside the system. Kinetic and potential energy of all the molecules present inside the system. Internal energy depends upon the temperature. internal energy depends upon temperature. Now, so forget about potential energy for the time being. Assume they have large separation, so no interaction takes place. For the time being, assume that. What is temperature? जिस चीज को आप बोलते हैं कि बहुत गर्म लग रहा है, what is that? The molecules arrives and hits your hand or your skin. With the larger velocity when it hits, means greater is the kinetic energy. Remember. So when it hits with larger velocity, you will feel what? More force. So this force, feeling of force is nothing but टेम्परेचर, फीलिंग पार्ट. तो आपने बोला कि गैस का टेम्परेचर ज्यादा है, इसका मतलब क्या है? जो मॉलिक्यूल्स हैं वो ज्यादा स्पीड से हिट कर रहे हैं. द स्पीड इज this as well as they are oscillating, they are vibrating, all these things are involved in that. But simple understanding is what? ये रहा मॉलिक्यूल आपका, ये आपके हाथ से टकराया. सेकंड केस में फास्टर. इफ इट हिट्स फास्टर you will feel more pain. That means temperature क्या हो गया? ज्यादा. That's the feeling about temperature. Remember, it's nothing but kinetic energy. Now, in head-on collision, let's talk about head-on collision a little bit. So suppose this is the molecule or atom of your skin, and this is the gas molecule. It comes and hits. It comes and hits. If you remember the case when both these balls had same mass, assuming perfectly elastic collision, for head-on, you simply what? Interchange their velocities. So what is going to happen? This thing comes and hits this thing, it will come at rest and this molecule starts moving. So you will say that you have transferred energy from this molecule to this molecule, thereby increasing its temperature and cooling this body down. So when you place two bodies in contact of each other, one hotter and the other one colder, what happens? Molecules in this body, which are moving with larger velocities, they come and collide with the molecules of this body, which are relatively at lower speed, and therefore collision process is increasing velocity in this hand, which is nothing but what? Transfer of heat. So अपने दिमाग में क्या रखना है आपको? टेम्परेचर का मतलब क्या है? Kinetic energy. That kinetic energy, थोड़ी देर के लिए potential को भूल जाओ. That kinetic energy of all the molecules is what? U. Hopefully you understand meaning of U. So the statement which we have written, the last line was du. What is U? Du, change in internal energy, and internal energy is what? Kinetic and potential energy of all the molecules present inside the system. Now write down internal energy depends upon the temperature. Internal energy depends upon the temperature. If temperature is increased, du is positive, and if it is decreased, du is negative. You can draw a similar figure with dq also. If heat is supplied then dq is positive. If heat comes out, then dq is negative. You can also draw these as a side note. So when temperature is increased, internal energy increases, and if internal energy increases, then du will be what? Positive. D means what? Change. If you increase T, that means you are increasing kinetic energy. That means you are increasing U, and therefore du is what? Positive. If you decrease T, that means you are decreasing their kinetic energy. You are decreasing U. If U is decreased, that means final is less than the initial, and therefore du is what? Negative. Anything D type is what? Always final minus initial. So when you decrease this, U final is less than U initial. So if your U final is less than U initial, U final is less than U initial, then because of the negative sign, you will get what? Negative du. Now let's talk about dW. Third point. dW is work done by the system. Now remember, always these things are very small as long as you are saying d. dq is what? Small heat supplied. du is what? Small change. dw is what? Large change. And when you remove d, you know that is called what? Integration. So dW is work done by the system. By the system means by the gases. Remember, in chemistry, when you are taught thermodynamics, dW is work done on the system. And therefore, if you have been taught thermodynamics in chemistry, you must have seen there appears a negative sign here. Well, don't worry about that, what happens in chemistry. Let's talk about physics, and you will understand chemistry also with the help of physics. What is dW? Work done by the system. Let's write down a point first, and then I will explain dW further. If volume of the system increases, then dW is positive, and if volume decreases, then dW is negative. If volume decreases, then dW is negative. Let's first understand this plus and minus, because this is something which is coming from work, definition of work. Look here. This is the piston. All the gas molecules which are present inside, they are moving, and as they move, they hit walls of this container. That means this piston also gets a force because of the collision with the molecules. So these are the gas molecules, they are moving and they collide with the piston, and as they collide they exert what? A force on these. And I hope you understand that collision force will always act towards the body. Why? Because it's a normal reaction force. So when two bodies collide, the black marker is pushing the red marker up and red marker is pushing the black marker down. So all the gas molecules, when they hit this piston, there is an upward force acting on it. Piston area is A. So what is pressure? Same thing which we have seen in fluids. Pressure will be what? F upon A. Now, this is the initial volume, V initial. And because of this force, piston now moves and takes this position. Let's say it travels this much, which is dx. पिस्टन यहां था, मॉलिक्यूल्स टकराए, फोर्स लगा और ये शिफ्ट हो गया यहां पर. अगर ये यहां शिफ्ट हो गया, then what is work? Work is always what? F dot ds, force dot displacement. How do you open dot product? Magnitude of F, magnitude of ds, which is dx, into cos of 0. फोर्स कहां लग रहा है? ऊपर. डिस्प्लेसमेंट भी ऊपर, इसलिए एंगल क्या बनकर आया? 0. What is F? P into A multiplied by dx. You know what ADX is? Who will tell me what ADX is? Fast. What is ADX? बच्चा टाइप चीज है, हर आदमी बता सकता है. What is ADX? ADX means now molecules occupy this much extra space, shown in red. Earlier they were confined in the V initial region, but now as piston moves and occupies this position, you have this much additional extra volume. So what is ADX called? ADX is called dV. A into dx is what? dV. Now, दुनिया की किसी भी प्रोसेस के लिए थर्मोडायनेमिक्स में आप अब ये याद रखोगे that dW is pdV, and you don't have to then worry about direction of force, direction of zero or anything like that. What do I mean by anything like that? उसको देखते हैं इस एग्जाम्पल से. फर्स्ट ऑफ ऑल, अगर वॉल्यूम इंक्रीज होगा, तो dV क्या होगा? पॉजिटिव. व्हाट इज dV? dV का मतलब क्या है भाई? dV, any d is always what? Final minus initial. अगर आपका वॉल्यूम इंक्रीज हो रहा है, that means this number dV is positive, V final is greater than V initial. अगर वॉल्यूम डिक्रीज हो रहा है तो V final is less than V initial and therefore dV will be negative and therefore dW will be negative. लेकिन आपने क्या सीखा हुआ है वर्क एनर्जी में? आपने ये सीखा हुआ है, and who will tell me this? In this figure, if I say that volume decreases, in this figure, if I say volume decreases, then what is the direction of force? Up or down? Write down fast in the comment box. If volume decreases, then what is the direction of force? Up or down? Good. बहुत सही. It will be up. Now tell me, if volume decreases, what appears in place of 0? Write down fast in the comment box, and the moment you write it, you will yourself understand meaning behind negative sign. If volume decreases, then what appears in place of 0? Good. अगर वॉल्यूम कम हो रहा है तब भी ये फोर्स कहां लगेगा? ऊपर. Why? Because it's a normal reaction force. But if volume decreases, if somebody says that piston is here, this is the force, but we have to decrease volume. This arrow means volume is decreasing. This arrow shows the direction of force. Then the piston from this position will now occupy this position. If it occupies this position, that means piston is coming down, shown with this right arrow. I hope you can see the right arrow. This right arrow is your dx. If this is dx, you will be writing what? dw as force into dx, this dx, into cos of pi 180. And what is cos 180? -1. Therefore, you get dw as what? Negative. ये चीज तो क्या बन गई? वर्क इन थर्मोडायनेमिक्स, उसको हमने अपना सिंपल मैकेनिक्स में जो वर्क था उसके साथ क्या कर दिया? रिलेट कर दिया. So if there is any confusion anywhere in physics or chemistry or in anything, you can always use what? F dot ds. लेकिन अब आगे से आपको कंफ्यूज होने की जरूरत नहीं. In physics, if they ask you what dw is, it will be always what? P dv. Always P dv. And what is dv? V final minus V initial. If volume is increasing, dv is positive. If volume is decreasing, dv is negative. मैंने केमिस्ट्री की बात की इसलिए हल्का सा रिलेट करा दूं. इन केमिस्ट्री दे से वर्क डन ऑन द सिस्टम. तो वहां क्या हो रहा होगा? इस फोर्स की बात नहीं कर रहे. देयर इज अ फोर्स कमिंग फ्रॉम आउटसाइड. तो अगर आपने एक फोर्स बाहर से लगाया हुआ है, पिस्टन ऊपर जा रहा है. अगर पिस्टन ऊपर जा रहा है, then for this force you have the angle of 0. But for the other force which is coming from outside, piston is going up, you'll be using pi in this figure. What happens here? This is the force coming from the system. In chemistry they use work done by the external, outer system. Force is down, piston is also coming down. If they both are coming down, then instead of 0, instead of pi, you will be taking what? 0. तो वहां प्लस का माइनस हो जाएगा, यहां माइनस का प्लस हो जाएगा. वो लोग यहां पर प्लस की जगह क्या यूज करते हैं? माइनस. इसमें कहीं कोई चेंज नहीं है. दोनों चीजों का मतलब क्या है? सेम है फंडामेंटली. Note down this much, and if you understand everything so far regarding dq, du, dw, the plus and minus sign and all, then write down yes in the comment box and note down everything. Well, one of you is asking that at one place it is p dv and the other place it is f dx. They both are same. F dx, that's all you are taught. Work in work energy, force multiplied by displacement, and cos of angle between force and displacement. For gases, we are not interested in the movement of piston. Instead, we are interested in the volume change, and therefore replace F using this formula. F becomes what? P into A. Put it here, multiplied by dx. This A dx, A into dx is what? dV. So with gases and all, we are not interested in displacement. We are interested in what? Volume. With gases and all, we are not interested in force. We are interested in what? Pressure. And therefore this is P dV. Now, whatever is the case now, this is the generalized version. If volume is increasing or it is decreasing, you don't have to worry about it. dV will take care of that. We'll see and solve few examples and you will understand this part. Hope this thing is clear. You write f dx or you write p dv, they both are fundamentally same. Now let's understand meaning of this. और एक सिंपल एग्जाम्पल से समझते हैं इसको. I gave you 100 rupees. I gave you 100 rupees. And out of this 100, you kept with yourself 20 rupees. And 80 you transferred to someone else. This is first law. This is conservation of money. Conservation of money. 100 I gave you. You have got 20, 80 you gave to someone else, 100 is 20 plus 8. This is COE. This is COE. Conservation of what? Energy. So thermodynamics first law is all about conservation of energy. But for your understanding, you can draw these things. 100 is given. That means is received by the system, and when system receives, it is always positive. Du is change in internal energy. This 20 is the amount of energy which is capped by the system. It increases the temperature, but it could not control all the energy given to it. So what it did, in the process, this piston moves up. Now, let me tell you what this 80 is, if you can visualize this also. Let's connect a rod, and the rod is connected to a wheel. A simple diagram and you will understand meaning of 80. This is a piston. When you supply heat, these gas molecules, they move, collide with the piston, piston goes up. As the piston goes up, this crankshaft, this rod is going to push the wheel, is going to produce what? Torque, and because of that torque, this thing is going to rotate. A simple figure है आपके समझने के लिए. And as it rotates, the wheel gets what? Half I omega square. You know what half I omega square is? 80 वर्क. तो हमने क्या किया? हमने 100 दिया, 20 सिस्टम के जो गैस मॉलिक्यूल्स हैं उनका टेम्परेचर बढ़ गया, बचा 80. पिस्टन के मूव करने की वजह से ये जो व्हील रोटेट कर गया, इट गेन्स व्हाट? काइनेटिक एनर्जी. कहां से आई काइनेटिक एनर्जी? इस पिस्टन ने ट्रांसफर की. दैट इज योर 80 joules. So this is the feeling part associated with first law, which also gives us a short answer type thing. What is first law based on? Conservation of energy. Do you understand this visualization? Yes or no? Fast. Good. Note down these values for your understanding and show these arrows. This arrow is for the system part. All gas molecules collectively, they are called what? System. So 100 is given, 20 is held by the system, 80 is released. Write down the statement also. First law of thermodynamics. First law of thermodynamics is based on conservation of energy. First law of thermodynamics is based on conservation of energy. Now, let's talk about work first. There are standard processes for which we find work. There are very important results. So, for any competitive examinations, you will remember the results, and for your school and all, remember the derivation. First, we'll take an isobaric process. We have discussed this type of thing: isobaric, isochoric, and all. Isobaric, isochoric, and all these things. You have heard these names when we were discussing bulk modulus and all. But again, what is isobaric? When pressure is constant. So we need to find work if pressure remains constant, same throughout, and volume changes from V initial to V final. I'll give you 30 seconds. Write down this work in the comment box. Only thing you need to know is what dW is always PdV. And you can yourself find work done by the system in an isobaric process. Isobaric means pressure remains constant. Volume is changing from V initial to V final. Should not take more than 30 seconds. Good. How do you find W? What is W? Integration of dW. That means integration of P dV. Can I take this P out? Yes, because P is constant. What is integration of dW? W. What is integration of dV? V. But now you must use limits. So we are increasing or changing from V initial to V final. Lower limit, upper limit. How do we put limits? V final minus V initial. This is work done by the system or a gas in an isobaric process. Very easy derivation. P V final minus V initial. Put on this. So those who have written dV, remember, you left it only as P dV. What is dV? Small change. What is V final minus V initial? Any type of change, small or large. Now let's see who will answer this. Its pressure is constant, but when volume was V initial, temperature was T initial. When volume is V final, temperature changes and becomes T final. So who will answer? Who is going to answer this work now in terms of temperature? Write down in the comment box, work done in isobaric process in terms of T initial and T final. And not a single answer. Now let me give you a hint. Have you seen this equation? Well, you don't have to write down yes in the comment box. I know that you all have seen this equation. So PV is what? nRT. Now can I expect an answer in terms of T? Not taking too long. क्या हो गया भाई? इधर. This equation tells us when pressure is P, volume is V initial, and R T initial. Number of moles, R is gas constant, T is T initial. Then pressure is P. It's not changing, pressure is same. Volume is what? V final and R T final. और मैंने आपसे क्या पूछा है? मैंने आपसे पूछा हुआ है PV final minus PV initial. PV final minus PV initial. What is that? This is coming N R T final minus T initial. This is work done in an isobaric process in terms of initial and final temperatures. Note down this. So this was about isobaric. Now write down isochoric process. Isochoric means constant volume. So write down this. In an isochoric process, pressure changes from P initial to P final. Pressure changes from P initial to P final. And temperature changes from T initial to T final. Find out work done by the system. Find out work done by the system. Write down the answer in the comment box. Well, it took you so long to answer such an easy thing, and only 2-3 have answered so far. Isochoric. This is just for your confusion only, to create confusion. What is isochoric? Constant volume. Constant volume means what is dV? 0. Khatam. Work done is also what? 0. कोई इंटीग्रेशन नहीं करना, कुछ नहीं करना अपने को. The volume is same. If volume remains same, then what? No work. And you know why there is no work? If you say volume is constant, remember there was a piston here. If you say volume is constant, that means that piston is not moving. If piston is not moving, then what is the displacement? 0. If displacement is 0, what should be the work? 0. So, straight away, W is what? 0. Since dV is 0. Now, this is a result for your school examination, for NEET type of examination. And what is work done by the system in an isochoric process as pressure doubles? कोई टेंशन नहीं लेनी कि प्रेशर डबल हो गया कि क्या हो गया. Isochoric, they are basically asking you what? You're trying to push something, but you're not able to move it. How much work did you do? अरे यार जब पुश ही नहीं कर पाए उसको, मूव ही नहीं करवा पाए, तो कितना वर्क किया अपन ने? 0. That's what is happening here. Whatever you do with pressure, आपका work, since dV is 0, is 0. This is for isochoric. But only 1, 2, 3, 4, 5, only 5 could answer 0. Now, write down isothermal process. What is isothermal? Everybody knows. We need to find work. Your T remains same. Volume changes from V initial to V final. And pressure changes from P initial to P final. क्या चीज चेंज नहीं हो रही है? T. Volume change हो रहा है, pressure change हो रहा है. And you need to find work. Any process in thermodynamics, if they ask you what is work, you will start with what? dW PdV. And then you will start integrating the whole thing. This will give you W. For any type of process, you have to use this thing. So I'm giving you 1 minute's time. Let's see who can find me an answer for isothermal process. Well, one of you has tried to answer this thing and is close. Now look at the proper procedure. When it was an isobaric process, you could easily take this P part out because P was constant. In this P dV, some of you try to integrate this P dV like this. P integration of dV is V. Some try to integrate this in this form, P square by 2 V. Well, you cannot integrate in this form because it's not x dx. Whenever you have x dx type of thing, we use x square by 2. So you've got P and dV, and they both are changing. So how do you integrate this? For integration, you should have only one type of variable. Either everything should be in terms of P or everything should be in terms of V. But look here, this equation tells us that P can be written as nRT divided by V. That means this P is nRT divided by V dV. Well, can I expect an answer now? If you try now, you will remember the steps. It will be easier for you to remember everything. I've given you a small hint. Integrate this. Use limits from V initial. Why V initial? Because this is dV. From V initial to V final, use the limits. And I'm sure you can do this. It's very easy. You can. Well, some of you got it correct. Well, none of you have got it correct. None of you have got it correct. I've got 4 responses so far and none is correct because of very small silly mistakes. What is log A minus B? This is not log A minus B. Well, one of you ultimately got it correct. The point is that, look here. What is integration of dx upon x log x base e? भाई ये आना चाहिए, ये बहुत पहले की चीज है. This is taught in the month of April. If somebody is interested in lectures, these type of lectures, integration of spatial functions, send a request and I will give it to you. It's log x e, and if you're also not comfortable with log and all, then again you can send a request. So log x e in short is called ln x. Right now I'll assume that you are comfortable with this. If you are not, write down this as a side note. dx upon x log x base e. क्या होता है base? Go and see the lecture on log. Log x on base e is called ln x. nRT is constant. N is constant, R is constant, T, it is given that is a constant, dV divided by V. What is dV upon V? dx upon x. What is the integration? Log x. So what is the integration? Integration is coming N R T log of V. V initial, V final. Now, how do we put limits? nRT log V final minus log V initial log V upper limit minus log V lower limit. अब यहां देखना, there are two possibilities. Some of you have written log V final minus V initial. There may be two reasons for this. I don't know what made you write this, but if you are using limits only for V and then you are writing V final minus V initial, no, that's not how we use limits. V final and V initial, they should be used with complete function. This is ln V. Upper limit means ln V final minus ln V initial. This is one of the reasons. If you have done something like this, remember it's not valid. The other thing is, maybe you thought in this way, log A minus log B. If you thought that we can take log common and we can write it as log of A minus B, then again this is wrong. Log A minus log B, you cannot take log common. It's log of A. It's like sine 30, sine of 30. You cannot take simply sine as a common thing. Sine 30, sine aapne bhag le liya. It doesn't make any sense. So you cannot write like this. What is log A minus log B? I hope you remember. If you do not, then remember now. It is log of A upon B. Log A minus log B is log of A upon B. That means this is coming, remember, N R T log A minus log B, which is log of V final upon V initial. The whole V final upon V initial is with log. This is work done by the system in an isothermal process. nRT log V final upon V initial. Good. Now, finally, I see the correct response. So those of you who could not answer this thing, do you understand the derivation, yes or no? Good. Last thing. Get me work done in terms of, this work is in terms of V final and V initial. I want you to write work in terms of P initial and P final. And those of you who find these types of things difficult, don't forget to write these things as a side note. That's not how we use limits. We don't use limits with v alone, we use limits with the entire function. And similarly, log a minus log b is not log a minus b. This is log of a upon b. And also this formula which I gave you. And now I want an answer in terms of P final and P initial. Not a single response. Look here. P initial, V initial is nRT, which is P final, V final. Because T is same, always isothermal. So P initial, V initial is P final, V final. What you are saying? You're saying this P initial, V initial is P final, V final. क्या चाहिए अपने को? V final upon V initial. What is V final upon V initial? P initial upon P final. And therefore, this thing, which is work done in isothermal process, in terms of pressure, becomes log of, this is V final upon V initial, in terms of pressure, it is P initial upon P final. If you understand this, write down yes in the comment box and then you can leave. Thank you very much.